Good afternoon, everybody. My name is Sean McGowan. I'm the Director of Member and Chapter Services with AFCEA International. I want to welcome you to the St. Leo University session titled Privacy and Security Issues in Big Data and Data Mining with Dr. Vyas Krishnan. This session qualifies for continuing education units. It must be a minimum of 59 minutes to qualify, and you must be present for the entire session. So please do not try to get your badge scanned early. It is my pleasure to introduce Dr. Vyas Krishnan. Dr. Krishnan is an associate professor of computer science at St. Leo University. He earned his Ph.D. in computer science and engineering from the University of South Florida. His professional and research interests include computer architecture and systems design, cybersecurity, artificial intelligence, engineering design optimization, and algorithm design. Dr. Krishnan has published his research in several peer-reviewed journals and has presented his work at numerous international conferences. Please join me in a warm AFCEA welcome for Dr. Krishnan.
All right, good afternoon, everybody. How are you all doing today? I'm sure it's been a long day for you all, right? So at the end of the afternoon, let's try to make it interesting, okay? As you can see from the title, from the main thrust of this talk is to look at how big data can impact privacy. Okay, we live in a society where data is everywhere. Data is the new oil. Corporations, big organizations use data to drive business decisions. So if you look at the landscape of big data itself, you can see analytics. You keep hearing about data analytics. You see data analytics drive, for example, decision-making in a lot of organizations. So we mine through a lot of data to identify opportunities, for example, for new venues to grow your business, new market opportunities, how to identify customers that would stay around, how to identify, for example, delinquent borrowers of loans, et cetera, et cetera. So a lot of the decision-making that happens in big organizations nowadays is very data-driven. And also, when you're looking at customer service, okay, nowadays, in this environment, in a highly hyper-competitive environment, customers are looking for the best service that they can get. And a lot of the types of services, the types of options that the companies can offer is determined by the type of data that you can gather in terms of customer response, what services work, what kind of preferences customers have, where to target customers, and so on. So a lot of customer relations management is data-driven. So again, analytics is a big deal. Security intelligence, military deals with a lot of data analytics in the security operations. So again, that's another area which is front and center in terms of data analytics. Now, a lot of operational analysis of businesses to optimize business processes is also data-driven. So the fact of the matter is we have to realize that we live in a society where big data is front and center and impacts a lot of aspects of not only in the commercial sector, in the military sector, but also on a personal level. So when we talk about big data, I'm sure some of you might be familiar with this terminology. When we talk about big data, the term big doesn't necessarily refer to only volume, not just the size of data, but also we talk about a variety of data types. So you're not only dealing with numbers and textual data, you could be dealing with multimedia content. You could be dealing with web feeds, for example. You could be dealing with Facebook posts and so on. So you have a large business transactions, purchase transactions, et cetera. So you have a large variety of data types, and you also have a variety of different sources of data. And all this data is being generated at a high volume at a very high rate. So typically when we talk about big data, it is characterized by what is known as 5V. So you have large volumes of data. Now, when you talk about data volumes, it's not megabytes or gigabytes. You're talking about petabytes of data. Okay, so large volumes of data. You have data that's being generated at very high rates. So you have streaming data, for example. You have sensors feeding data. So you could have millions of sensors or thousands of sensors in a large manufacturing facility, and the sensor data is being analyzed to identify, for example, plan preventive maintenance or identify issues with either the product flow, et cetera, et cetera. So you could have large volumes of data being generated at a high rate. You also deal with a large variety of data types. You're dealing with, as I mentioned earlier, traditional types of data such as numbers and text, et cetera, but you also are dealing with, let's say, electrical signals from sensors. You're dealing with web feeds. You're dealing with web logs. You're dealing with customer sentiment analysis based on the types of posts that they make, et cetera, on the web. So you have a large variety. You also have different ways in which the data manifests itself. Okay, so you have the statistical data. You're looking at, you could be looking for events triggered by data. You could be analyzing correlations between different data streams. You could be looking at how you can hypothesize. You can sort of do forecasting based on data analysis and so on. So you have a lot of different types of values generated by the data that's being handled in big data analytics. And finally, you also should be able to weed out the noise. So a lot of times the data, let's say you're doing customer sentiment analysis based off of customer posts on web logs. So you should be able to filter out fake news, for example. So veracity is also sometimes an important factor depending on the type of data that we're dealing with. So going back to the definition of big data, now if you look at it, the variety and the volume of data could come from different sources. So here, this gives you a sampling of the types of data that you deal with in a typical big data scenario. And the data is not only coming from things such as web logs and so on. You could also have data that's being tracked. So a lot of personal devices, for example, such as your Fitbits, your Fitbit data could be your devices would be uploading your biometric data to a server, so you can run analysis and determine how you can more efficiently design, customize a workout for you, and so on. So the moral of the story is a lot of times when we collect data and process the data to drive business decisions or to derive some utility from the data can consist of a lot of personal information. Okay, and we use what is known as data mining to analyze the data to look for patterns that would educate us to carry out to make informed decisions. So the process of data mining must be done in such a way that not only the data that is provided for the data mining operations is sanitized so as to remove personally identifiable information, but also depending on where and how the results of data mining is used, okay, you have to ensure that the results do not divulge either intentionally or unintentionally sensitive information. Okay, so now again, going back to this slide here, the biggest driver for big data is value, what value it can generate. And regardless of the different industry sectors, you're talking about big data can provide a lot of value for making informed decisions, decision-making process. This slide here gives you a snapshot of some of the common areas where big data analytics is commonly used. Okay, so for example, marketing and customer analytics is huge in big data. If you look at, for example, threat analysis, cybersecurity nowadays, machine learning and data analytics is huge in being able to identify in real time a lot of cybersecurity threats that organizations experience. Then risk analysis is again another area. For example, financial institutions use big data analytics to identify high-risk loans, for example, or to determine credit rating, et cetera. So again, if credit card fraud is also, again, triggered by risk analysis. So many of these applications make use of large volumes of data from a variety of different sources. And a lot of the data can consist of sensitive information. So how do we ensure that when we do data analytics, when we do data mining, we do not unintentionally divulge sensitive information? So that's pretty much what we'll talk about in this presentation. So what's the challenge? The challenge is to ensure that the data that is used in big data analytics and data mining is used correctly. So you abide by its intended use, you abide by compliance laws. We also should be able to track how this data is used, transformed, and derived. Now, if you're in cybersecurity, you know that there are great techniques, there are processes in place whereby you can identify any network intrusions. A lot of techniques that are out there. But when it comes to control of the data that people provide to data miners, a lot of times we don't have, once the data is released, we don't have control of how the data goes, the trajectory that the data takes. A lot of times we realize that PII, personally identified information, has been compromised months after the incident has occurred. See the point? So a lot of times privacy is a huge issue in big data analytics. So this is a cartoon that sort of conveys the idea. Big data privacy is. So we have these large amounts of data, different types of data. Now, what do we do with the data? How do we utilize the data to derive useful information out of it? So the process of how we can go about doing that is what's called data mining. Okay, so why is data mining necessary? Primarily because if you look at it, we have large volumes of data. We have excellent ways in which we can collect and archive the data, but how to derive actionable knowledge out of the data, that's the biggest challenge. Now, data mining is an evolving field. A lot of the work started in the early 90s, and it evolved from database technology. Because database technology was very good in dealing with traditional data, relational database tables, et cetera, et cetera. But when it comes to the type of big data that we deal with, variety, volume, and the velocity with which the data is generated, the traditional database techniques were no longer adequate. So data mining evolved out of some of the ideas of database technology. So what exactly is data mining? Data mining is a set of algorithmic techniques that can essentially sift through large volumes of data to identify specific patterns, okay, in the data. If you can identify patterns, that can give you insight as to what the data conveys. For example, if you're looking for non-trivial or implicit piece of information, for example, let's say if you do data analytics, if you look at sales information, and if you can identify, for example, Walmart did a study where it determined based off of data analytics or data mining of its sales information that toothpaste and diapers, they sell heavily on Tuesday and Thursday mornings. Okay. Now, information such as those is not immediately obvious. So data mining can allow an organization to be able to locate such associations, such patterns based off of the mining operations. So essentially, the purpose of data mining is to discover valuable insights and use those insights to make predictions. Okay? So what are some of the potential applications? Marketing is huge in using in data mining and data analytics. For example, targeted marketing for customers, customer relationships management, okay, market segmentation are some of the huge areas that heavily uses data mining to identify potential markets or identify potential product lines to sell. Okay, fraud detection is again another area that heavily depends on data mining. Now, you might have seen those commercials on TV, LifeLock, right? LifeLock can tell you real time if there's somebody is trying to use your credit card. How is it able to determine that? Through data mining. Okay, so fraud detection, again, in the finance sector, the data mining is heavily used. Risk analysis and management is, again, another area. Now, for example, let's say you want to start a new business location. You want to start a new factory at a different location. How do you make an informed decision as to whether it's a viable strategy? A lot of times, you can do data mining on demographics, on the supply chain, logistics, and things of that nature, and use the mined data to make informed decisions. So risk analysis, again, is a huge area where data mining can be applied. Now, this is not an exhaustive list, just a sampling of some of the areas where you can use data mining. Other applications, for example, text mining, sentiment analysis is another area where data mining can be extensively used. Now, the field of data mining itself is a combination of a variety of different disciplines. Okay, so for example, the algorithms themselves fall under computer science, but you also have an intersection of machine learning, pattern recognition, database technology, out of which data mining evolved. Then a lot of stat and math goes into data mining. Okay, a lot of the data mining algorithms utilize statistical techniques. And then you also have visualization, because the data mining results must be presented to decision makers in a digestible format. So instead of presenting them with huge complicated tables, you might have, if you've used tools such as Tableau or Excel Miner and Excel, et cetera, you have a lot of very nice visualization tools that can distill the information presented in an easily digestible format. And that itself is a huge discipline, because you can use a variety of different types of visual aids that are most efficient in being able to convey certain results. So being able to identify the most efficient visual tool to convey the data mining results is an art as well as a science, and that's a huge area itself. So if you talk about data mining, it's a confluence of several different disciplines. Okay. Now we'll mainly focus on a subset of the algorithmic aspects of data mining in this presentation, and we'll look at how we can ensure that the data that is presented to a data miner is anonymized in such a way as to prevent inadvertent divulgence of sensitive information to both the data miner as well as to the decision makers who look at the results of the data mining process itself. Now, to sort of put things in context, let's very quickly look at the whole data mining process, because that'll give you the background information on some of the privacy issues that we talk about when we look at data mining itself. Now, data mining, a lot of times, is not just mining data. It involves several stages, because there's a preparation stage, and then there's the mining stage, and then there's the post-mining stage. So if you look at the preparation stage for data mining itself, now you could have large data archives. Now, depending on what specific type of information that you're trying to mine from the data repository, in the pre-processing stage, you're looking at identifying those elements of the data repository that you need to provide to the data miner. And a lot of times when you provide data to the data miner, there might be missing data, there might be inconsistent data. If you, depending on the type of data feed to the data miner, you might have noise. If you're looking at, for example, sensor data, you're mining some information from sensor data, you might have noise. So you want to be able to handle, remove noise, reconcile missing and inconsistent data, and so on. So some of the prep stages are collectively called data cleaning. And then finally, you may have your data sources, your data coming from multiple sources. Let's say you're conducting a survey, sample survey, and you collect data from a variety of different customers. They may not all be located in this, all the collected data may not be in a central place. Sometimes for security reasons, you want to partition the data over multiple locations. So a classic example is you have insurance data and you have patient record data. They are in separate repositories. So if you want to be able to mine information from both the data sources, you need to be able to combine them. So a lot of times data integration is not a simple matter of putting it all together in a single file. They may be in different formats. So data integration might involve several substeps themselves. So several stages of pre-processing is necessary before we are in a position to proceed with data mining. Now, once we have pre-processed all the data, now when you talk about data mining itself, there are different types of data mining algorithms that are out there. Now, I'm not talking about specific algorithms, but broadly, you could look for example, identifying patterns, different data patterns. They're called association rules. Okay, you could be classifying data into different types. Okay, so you call data classification. You could be looking at disparate data and identifying clusters of similar data. So it's called data clustering. Now, all those different algorithms work in different ways. So depending on the type of data mining technique that we are looking at, once we have processed the data, the next step is to transform the data into a format that can be fed to the data mining algorithm. So the transformation phase, a lot of times you're looking at which features the algorithm needs to focus on for the mining purposes. It's called feature selection. And depending on compatibility or incompatibility of the way those features are expressed, you could have feature transformation. So those are the primary steps involved in the data transformation process itself. Okay? And once we get to this stage, then we are in a position to proceed with the data mining itself. Okay? Now, when we talk about data mining per se, there are a variety of different techniques, but broadly, you have three major classes. You have determining association rules, called association rule mining, and then we have determining classification rules, and then identifying clusters. Now, in simple terms, association rules look for patterns in data where you can associate some behavior with another behavior. For example, let's say you have what's called market basket analysis. Okay, that's a category of data mining techniques whereby you can look at customer shopping habits and identify, for example, which items that customers typically buy. So let's say somebody, the frequency with which customers, let's say, buy shampoo and cigarettes and diapers. Okay, so let's say if you see a recurrence of these three items being purchased by a number of customers, then that's a pattern. Okay, so these three products are associated in customer buying habits. If you look at travel destinations, for example, so if you mine the travel data from a lot of customers, so if you have a travel agency, and you identify, let's say, what packages sell a lot in terms of travel destinations. So that would allow you to identify association patterns. Okay, this package, when it's associated, this package seems to be very popular among customers. So that kind of association rules can be very efficiently mined using data mining algorithms. A lot of algorithms that exist out there that do that. Then you're looking at clusters. For example, law enforcement can look at crime statistics and identify areas where you have clusters of areas that have high crime rates. Okay, so again, this is another set of techniques that allow data mining to identify patterns in data. And then classification rules come in handy. For example, when you want to classify high-risk borrowers, low-risk borrowers, and things of that nature based on the customer behavior. So the different algorithms that determine, that mine for these kinds of data, they differ, okay? And that's what data mining is all about. But if you look at the hundreds of different data mining techniques, you can a lot of times you can broadly categorize them into three different categories. So once the actionable information has been mined from all the data, the next step is to present it to the decision makers that can make sense of the data. So this itself is a whole area. So a lot of the data presentation falls under visualization. How do you use visualization techniques to be able to present this data in a manner that's digestible to the decision makers? So now let's look at, so we've seen the process of data mining itself. Now, depending on the kind of data that's mined by the data miner, a lot of the data could deal with sensitive data. So how do we ensure that the mining process does not leak sensitive data, personally identifiable information, and so on? Now here, I'll give you a couple examples to sort of put things in context. Now, in 2012, Target received complaints from a customer who was very angry that Target was mailing coupons for baby clothes to his teenage daughter. The father did not know his daughter was pregnant. Okay, how did Target find out that the daughter was pregnant even before her parents did? That's because she was using web search in the Target website to look for products. Okay, and essentially it sort of used data mining and rule association to guess that this particular customer is probably, if they're looking for a lot of baby products, probably pregnant. So they sort of inferred based on the browsing habits what the customer is most likely to have. So that's one example. Have you heard of the challenge that Netflix launched, Netflix Challenge back in 2006? Now, in 2006, Netflix launched a challenge whereby what it did was it released the movie rating records. It released a data set containing movie rating records of over 500,000 of its subscribers. Okay, so essentially, the data set was sanitized. So customer identifiable information was removed. So it only contained some random ID number followed by the name of the movie, what ratings the customer gave for the movie that was watched, and the date when the rating was posted on the Netflix website. The purpose of releasing the data set was Netflix wanted to open source a competition, sort of crowdsource a competition whereby it invited participants to come up with machine learning algorithms that can build better recommendation engines, movie recommendation engine. Okay. Now, when you want to develop a machine learning algorithm, you need a training data set, and that was the idea behind releasing this information. Now, mind you, the data set that was released did not have any directly identifiable information. Okay. Now, a year later, two researchers from the University of Texas were able to utilize the data set and prove that they can identify some of the customers that were included in the data set, some of the subscribers that were included in the data set. And how did that happen? That happened because of what is known as association. Okay, so you have identifiers which can be used to directly identify a person in a database, but you also have what are known as quasi-identifiers. Quasi-identifiers are a collection of attributes, let's say in a data set, that can be linked with specific records in a publicly available database. Okay? So they were able to do that and identify some of the subscribers that were anonymized in the data set released by Netflix. And a couple of years later, some of the people whose identity was revealed through that research, they sued Netflix. Okay, and Netflix had to withdraw the competition. So the fact of the matter is, just because personally identifiable information is removed from data doesn't necessarily mean that data mining cannot still reveal sensitive information. So that's a huge issue in terms of privacy when it comes to data mining. Now, if you look at big data itself, there's a lot of sensitive data that's out there, and it's shared by a large number of entities. For example, if you look at electronic health records, okay, the patient data is shared by it's shared with the insurance companies, it's shared with the hospital, it's shared with the hospital, it's shared with the pharmacy, et cetera, et cetera. So there's a lot of back and forth that happens. Now, agreed, we have regulations that protect privacy. However, those regulations only specify that identifying information cannot be revealed. However, if the identifiers are removed and if the data is mined, sometimes through quasi-identifiers, it's possible that some sensitive information can be some of the entities, some of the users in the data set can be re-identified. Okay? Now, here's another scenario where a lot of sensitive information is shared across multiple sources. For example, here, this figure here tells how many of the apps in your iPhone are shared with third-party servers. Okay, so this again. Now, your cell phone is loaded with sensors. Okay, so it has a lot of personal information. It also has location information, et cetera, et cetera. So this is another avenue through which personal data is being shared. And this data, even though personally identifying information could be sanitized from a data set, if it's mined for, let's say, any marketing purposes or piloting a new product, et cetera, there are still ways in which personal information could be compromised through data mining processes. So it sort of gives you an idea that even with the regulations, et cetera, data mining is still vulnerable, is still another avenue through which sensitive information could be compromised. Okay? Now, in the broad scheme of things, the primary purpose of data mining is to aggregate information. So data mining algorithms are not looking for specific identifying information. It's looking for patterns in aggregate. However, the results that are published by the data miner might have some attributes or some information that can be correlated with other external publicly available data sources, and that could de-anonymize some of the information that's presented in the data mining results. Okay? So one of the ways to sort of mitigate this is we sanitize the input data. We not only remove identifying information, but also we try to perturb or modify the quasi-identifiers, which I'll talk about shortly. We'll look at what we mean by quasi-identifiers and so on. So quasi-identifiers are piece of information in either the mining results or the input data to the data miner that can be utilized to link it with externally available sources to identify a person. Okay, so the anonymization techniques that we use to sort of sanitize the data before it's sent over to the data miner, it's a two-way street. Okay, if we remove some of the information, or if we perturb some of the information, we may lose data utility in the sense that the purpose of data mining is to identify useful patterns. If we add noise to the data that is sent over to the data miner, then we might lose accuracy of the results of the data mining. So it's a trade-off. So the key idea behind privacy preserving data mining is to balance these two keys, these two knobs. One is to how to de-anonymize the information that is supplied to the data miner, but at the same time, how to minimize the loss of usefulness of the data that is supplied to the data miner, such that it can pull out useful information. Okay, so the key task here is to develop accurate models so that you can have actionable information using the mined results, but at the same time, not disclose any of the sensitive information that is used for the mining process itself. Okay? So the two conflicting goals, it's sort of a multi-objective optimization problem if you view it as an optimization problem. If you look at privacy-preserving data mining, so the data that is provided to the data mining algorithms is sanitized in some way. So first, most obviously, you'll remove the identifying information such as name, social security number, etc. However, there are other quasi-identifiers that you may have to doctor to be able to minimize, reverse engineer, and identify information from the data mining results. So you want to make sure that the data that is supplied to the data mining algorithms is sanitized in an efficient way, but at the same time, you don't lose a lot of information as a part of the sanitization process. So that's the key goal here in privacy-preserving data mining. So when you look at the process of data mining itself, it's not something that's done necessarily done by one person. So in other words, you may not necessarily have one person or a group of people or one organization that does all the mining operations. You might have multiple players. For example, the data provided by the data provider could be processed and aggregated by an entity called a data collector. Okay, and obviously, if the data provider is careless in the type of information that they supply, that's one avenue through which the data could be leaked as a part of the transit process. Now, once the data collector has collected and aggregated all the information, okay, it's conveyed over to the data miner. Now, these could be the same person or the same organization, or could be entirely different entities. Okay, and so if you want to ensure that any sensitive information that is collected from the data provider is not compromised in any way by the data miner, the data that's handed over by the collector to the data miner has to be sanitized adequately. We'll talk about some sanitization techniques. And that's one of the steps that we need to take in privacy-preserving data mining. Now, once the sanitized data is presented to the data miner mines the data, identifies the results of the data mining, could identify aggregate information about the customer behavior, for example, from the data that is provided the data miner. Now, the data mining algorithms don't care about individual data. Okay, they work on data to identify patterns. Now, if the data that was provided to the data mining algorithm had information that could be used to identify individuals, then that information could be present in the results of the data miner. So how do we ensure that the results that are passed on to the decision makers do not have any sensitive information that's compromised in any way. So there are multiple places where, during the data mining process, where data could leak. And we want to make sure that in this entire cycle, or the different stages through which the data is processed, we follow a discipline whereby privacy is of primary concern. Okay? Now, in the interest of time, the main focus of this talk is this stage. How do we sanitize the data to make sure that sensitive information is not passed on to the data miner? So we'll look at some anonymization techniques that are used in tabular data as well as in social media graph data to ensure that sensitive information is not compromised. Okay? Now, to sort of put things in context and to provide a backdrop for defining some of the terminology that we will use to describe anonymization techniques, let's start with something that we can all be familiar with. Let's assume that the data that's being mined is provided in the form of a table. Okay? Now, in a typical table, you have fields and attributes and so on. So if you look at the different fields and attributes, you have 4 categories of attributes. These don't represent columns. We are not talking about columns or rows. We're talking about categories of attributes. So multiple rows here. Now, these are individual records in, let's say, in a database, and you have attributes associated with the individual records. Now, several of these attributes could correspond to the identifying identifiers. Several of these attributes could correspond to quasi-identifiers and so on. Now, identifying information directly identify an individual, things such as name, social security number, cell phone number, things of that nature. Okay? Sensitive attributes are the attributes that you deem sensitive. Okay, so things such as, for example, medical condition or salary or you can think of a variety of different types of sensitive information. Now, quasi-identifiers is one of the sources through which a lot of the data leaks happen. Quasi-identifiers are those where some of these attributes, even after the identifiers have been removed, if some of the attributes here can be correlated with data that's available from other data sources, then you could reverse engineer and identify individuals in a sanitized database. So essentially, attributes that can be linked with an external data to re-identify a record in a database called quasi-identifiers. Things such as, for example, when you sanitize the data, okay, you may sanitize the identifiable information such as name, social security number, etc., but the data that's provided onto the data miner might not remove, for example, the gender of the gender of the individuals in the record. It may not remove the zip code, for example. Okay, so the sensitive information under the disease category may be stripped out. Okay, maybe the age might be removed. Okay, and any other identifying information may be removed, and some of the other fields may be passed over to the data mining algorithm. Now, the problem is sometimes combinations of these quasi-identifiers can uniquely identify an individual. And some of these quasi-identifiers might be available in external data sources. So quasi-identifier is a lot of times, for example, going back to the Target example and the Netflix example, the source of the data leak was quasi-identifier. Okay? So what we want to do is we want to apply different types of anonymization techniques to the quasi-identifiers to ensure that sensitive information is not passed on to the data miner and therefore not reported in the data mining results. Okay? So if you look at traditional anonymization techniques, for example, if you have a database table and if you remove directly identifying information from the database table, assuming that that's enough to sanitize the data and somebody may not be able to re-identify individuals in the database table, that may not guarantee privacy. Okay? That may not guarantee the fact that individuals cannot be because we can use inference either as a part of the data mining process or as a part of looking at the result and correlating with other external data sources to re-identify individuals that have been de-identified in the sanitized table. So that's the problem here. Now, here's a very simple example. Now, if you look at there are a lot of public records out there that provide specific information. For example, if you look at voter records, if you look at real estate records registered in the county, if you look at school, for example, publicly available school records, et cetera, you have a lot of information that's available out there. So one study has shown that close to 87% of the population can be identified using some combination of this information. Okay, so let's say we have a patient health records, okay, which has been anonymized by stripping out identifying information. So these three attributes are passed on to a data miner. Now, somebody uses the quasi identifiers in this table and publicly available records in some an external database, and you can try to link those records with the quasi identifiers here and re-identify some of the individuals from this record. Okay. Now, web search logs, for example, contain a lot of information. Okay, and based on the search profile, an adversary can build a profile of the individual. Okay, again, if you look at this table here, the name or any other directly identifiable information is not present. Okay, it's not present in this table. It's been sanitized. You only have search queries. However, based on, if you look at some of this information here, you can sort of second guess. For example, here, you could statistically you can assume this is probably a woman, okay, and this woman lives somewhere in Georgia, okay, and is probably related to or is in some way affiliated with the person named Arnold, and is either looking to sell a house or purchase a house or research property in this particular county. So if you mine data from the search queries of a person, even if the data that's stored is sanitized some way, you can build a profile. Okay? And once a profile is built, this can be correlated to sanitized data, and that's the output of, let's say, some data mining algorithm. It's possible to re-identify individuals. So how do we? Here's another example. This article was published in the Nature magazine back in 2013, whereby a researcher was able to take data from a genome database that was provided for research purposes and correlate the sanitized data from this database with data that is publicly available in other repositories, DNA search, for example, and was able to identify some of the individuals whose DNA data was available in this sanitized record. So it is possible. So even though we can remove identifiable information from the data that is supplied to a data miner, it is possible. So because the mining results depend on the input data that is supplied to the data miner. Okay, so the more information the input data has, the more accurate the mining results, but at the same time, it gives away more information. And somebody can correlate the mining results with other data sources to identify, for example, who participated in a survey, or who belongs to which, let's say, which group or which category, things of that nature. So the problem here is we want to minimize what are known as linkage attacks and probabilistic attacks. Okay, so one of the ways in which we can model these kinds of attacks is look at how quasi-identifiers can be utilized to re-identify information from a database table. Now, if you look at the types of linkage attacks that can be used in Sanitize table to re-identify individuals, okay? Broadly, you can divide them into three different categories. You have a record linkage attacks, whereby you can identify a record of a target individual by linking some of the attributes, some of the quasi-identifiers of the record with an external data source. So you can link an entire record, so a record of a person in a Sanitize database with a record of the same person that's available in a publicly available database, so that's record linkage. Sometimes you may not be able to link an entire record, but you may be able to link specific attributes. Okay, so you have attribute linkage, and finally, you might, if an adversary is lucky, they may be able to link an entire table. So you have table linkage. So multiple ways in which quasi-identifiers can be linked to re-identify individuals from a sanitized record. You can also have probabilistic attacks. So here, if an adversary collects enough background information about their target, for example, if you go back to the weblog example, you can build a profile of the individual, and then based off of that, you can make a pretty good prediction as to whether the person's record exists in a sanitized database table, or if some of the attributes, if only some of the attributes can be tied, you can say with certain degree of probability if that person's record exists in the database table. So primarily you have linkage attacks and probability attacks. If you look at a lot of the data, a significant portion of the data is in tabular form. So these two attacks are avenues through which sensitive information can be compromised when it comes to data mining. So the most obvious step to mitigate this is to remove identifiers. Directly identifiable attributes will be removed. That's common sense. Anybody would do that. But what could be more challenging is, based off of all the attributes that are there in a database table, which among those are more vulnerable quasi-identifiers? So that could be a challenge. In the previous example, where you had voter record and medical record, it was a toy example. It's fairly easy to identify the quasi-identifiers. But if you look at realistic data tables that are mined by data mining algorithms, you could have thousands of attributes, and you could have millions of records. So now, the more attributes that you throw away, or you perturb, or you modify, the less accurate your data mining results. So it's a trade-off. So you have to be able to identify those attributes that are most vulnerable to data leakage, and be able to modify them in such a way as to mitigate revealing sensitive information. So that's both an art as well as a science, modifying quasi-identifiers. Okay. Now, there are several techniques that are used to modify these quasi-identifiers. Okay. I'll very quickly go over some of those techniques. The most commonly used technique, they broadly fall under what are known as data anonymization methods. You anonymize the quasi-identifiers in such a way that an adversary will not be able to link a particular record or a particular field to a corresponding record in a publicly available database. Okay. Once you're able to ensure that, then you can ensure data privacy. So we have what are known as K-anonymity. Okay, it's the most commonly used technique. There are different variations of K-anonymity. These two are essentially, even though they are listed as separate categories, they are variations of K-anonymity. Okay, so essentially, K-anonymity is the simplest form. It can be used to prevent or minimize record linkage that I talked about earlier, where you can correlate information, some of the attributes in the sanitized record with publicly some of the attributes in a publicly available, in a record in a publicly available database to re-identify an individual. So K-anonymity allows you to minimize doing that. L-diversity is a little more refined. It's an improvement over K-anonymity, and it can gives you a greater level of granularity. So it can not only mitigate record linkage, but also attribute linkage. Because sometimes it's depending on how much sanitization has happened in the sanitized database table and how much of information is available from publicly accessible databases, you may not be able to link records. You may be able to link specific attributes. So L-diversity and T-closeness gives you a greater level of refinement when it comes to minimizing record and attribute linkage. T-closeness also is effective to minimize probabilistic attacks, okay? Because in probabilistic attacks, you may not have the precise information of a particular entity from a publicly available database. However, you have additional background information, and you leverage that to make a best guess, with 80% probability, most likely this person's record is there in this particular sanitized table. So let's see if I can pull out, make an educated guess as to which of these belongs to that particular person. So T-closeness is another way of minimizing probabilistic attacks in addition to record and linkage attacks. Okay? Now, K-anonymity is simpler to understand, so let's look at K-anonymity to see how exactly that works. Okay? Now, if you go back to this table here, we have several attributes, right? So some of these attributes are quasi-identifiers. Some of these attributes are direct. For example, this one is sensitive information. Some could be direct identifiers. So if you look at K-anonymity, essentially what you do is you modify the values of some of the quasi-identifiers or the sensitive identifiers in such a way that every tuple of the quasi-identifier or the sensitive attribute is indistinguishable from at least K minus one other tuples. Okay. So let's see how that works out with a simple example. Going back to the same table here, now let's say instead of providing the actual age of each of these individuals to the data miner, we break them into groups. Okay? So we specify a range of ages. So instead of saying the exact age, we say, okay, this particular person falls in this range. Okay? So having determined a range, we can sort of break this into, we can group this into, these four people can be grouped into this group. Okay? Similarly, we can define other age ranges, and we can sort of de-anonymize that particular attribute. Okay? Similarly, instead of specifying the gender of the person, we could have a more general de-anonymization technique. Another way of de-anonymizing information is instead of specifying the entire field, we could suppress part or entire information. Okay? So these are some of the techniques that we can use to de-anonymize data that's passed on to a database table. So going back to K-anonymity, going back to this definition here, so what this says is if you modify some of the quasi-identifiers such that based off of any tuple that's modified, you cannot distinguish it from at least K minus one other tuples. So this is 2 anonymity. So if you look at it, okay, here any one of these is similar to 3 other. Okay, so the smallest subgroup here is 2. So once we de-anonymize a table, so in this particular case, it's called 2 anonymity because the smallest subgroup here contains 2 elements. So with this, we can say that there are at least 2 elements, 2 records here that are similar in some way with respect to this attribute. Okay? So that's what K-anonymity is all about. Now, this is a simple example. Now, in terms of anonymizing, there are multiple operations you can use to anonymize the database table. You can generalize, for example, or you can suppress. Now, going back to this table here, the gender was generalized to a larger subcategory called people. Okay, here partial information was suppressed. So you have generalization is one method, suppression. You can anatomize data. Anatomization, essentially what it does is it breaks the link between, let's say, an attribute and a sensitive information. So if you provide this portion, let's say this portion of the sensitized table as one table, and you break it up and supply this as a separate table, then your data miner could treat that as two separate tables. And you can also do other things. For example, you can permute the order. You can shuffle the order of some of these entries. You can shuffle the order of some of these entries. So those are some of the ways in which you can. So Anatomize does not modify the values of the attributes, but just subdivides a table into multiple tables. So you're separating out the attribute and the sensitive value. Permutation, essentially, you could shuffle some of the values, or you could combine that with anatomization. You can separate and shuffle some or more of the fields. So for example, going back here, you could just shuffle some of these fields, or you could shuffle combinations of fields, or you could shuffle just two sets of data and so on. So that's permutation. Perturbation is essentially modifying some of the values. So instead of specifying a range, for example, okay, you could add a random value to the range. Okay, so instead of saying 5 years, you could say 5 plus some from a standard distribution. You can add some value. So 5 plus 3, 5 plus 7, 5 plus 4, 5 plus 1. So some random value. So that way, the true value is suppressed. Now, why does this work? This works because when you look at data mining, you're not looking for specific individual data. You're looking for data aggregates. You're looking for patterns. So, for example, in this particular case, you could say, okay, the instance of this particular disease is most common in this age group. Okay, so if that's the kind of data that you're interested in mining, this information would suffice. You don't necessarily need specific age-specific information for each individual. See the point? Or if you're mining data whereby, okay, where does this particular product sell most, in which part of Georgia? Okay, then you only need county-level information. You don't need street-level information. See the point? So if we can use generalization, aggregation, perturbation, etc., you could still make mining operations work. But at the same time, you're suppressing opportunities whereby adversary can link your link-specific records based off of those quasi identifiers with the external database table and re-identify an individual. So these are some simple techniques that data miner can use to de-anonymize information that's fed to database table. Now, there's always a trade-off. Okay, depending on what kind of information we want to mine, the more generalization that we do, the more perturbation that we do, we are losing accuracy. Okay, it's a trade-off. And depending on which attributes are modified, you're almost done. Okay, which attributes are modified and which attributes are suppressed, we could lose some of the information. So that could reduce the utility of the data and the utility of the mining results. So it's always a trade-off. So there are different techniques that we can use to quantify the amount of data loss. I don't want to get into the details for the benefit of time, but there are methods whereby we could say, okay, if we apply this type of anonymization, if we apply this type of perturbation or this type of suppression, we can quantify what is the data loss, and that way that could help us guide which attributes to anonymize, which attributes to perturb, etc. Now, another interesting category of data that's often mined is what's called network data. Social networks, for example, is a classic example whereby network data is data mined. And they have a lot of practical applications. Representing data in the form of networks, okay, sees applications in a variety of different areas. Now, from a computer science perspective, network data is internally represented in algorithms as what's called a graph data structure. You guys familiar with the graph data structure? It's It's nothing to do with drawing graphs. Okay? Now, it's a way of representing data whereby entities. Now, network data has entities and relationships between entities. You could have customer-client relation. You could seller, buyer-seller relation. You could have a hierarchy in an organization. So you have entities and relations. So you could represent entities by what are known as vertices or nodes, and the relationships that exist between entities by what are known as edges, okay, or arcs. So it provides a very efficient way of representing this kind of information that can be processed by computer algorithms. Okay, so you have vertices, which are nodes representing entities in a network, and you have edges that connect the different nodes. Now, the way you represent information through vertices and edges tells a lot about the network that you're trying to represent. And you have data mining algorithms that are specifically designed to process that kind of information. And let's say you've mined, mined graph data, and then you have presented it in some form. Now, it's possible to reverse engineer data based off of what information an adversary has. Okay, so the adversary can have background information on the attributes of vertices, which is, let's say, the nodes could represent persons or organizations or entities, about the attributes of edges, the number of the arcs that are connected to the different nodes, this is called vertex degrees, the kinds of relationships that exist between different nodes called linked relationships, neighborhoods, and so on. So essentially, graph data is very rich in the type of information that you can encode. Now, I'm sure many of you might have heard of the Cambridge Analytica scandal, right? Now, a lot of the information that Cambridge Analytica mined was from graph data. Okay, so social network, Facebook data represents relationships between entities, and that is internally represented as graphs. So graph data is also used extensively for data mining operations in a variety of different sectors. So to give you a quick idea of the kind of data mining that happens with graph data. Now, let's say we represent a bunch of entities and their relationships using this kind of a graph. Okay? So here you have different people. These edges represent friends so you friended some person in Facebook. Okay? So you could create you could represent that social network in the form of a graph, and the friends between different persons representing the graph are represented by these edges. So here we have the original data that is internally represented in some database corresponding to different people and their friends. Okay? So let's say we want to send this data over to a data miner to extract some information. Okay? So the most obvious thing that we would do is remove all identifying information and replace them with random labels. It's called simple label anonymization. So if you can represent, so we are primarily interested in the relationship that exists between the different entities in the network. So we are looking at the structure of the network. So one way to a simple way to anonymize the network is to just strip out the identifying information and replace them with labels. Okay, so this is a naive anonymized network. Now, do you think this is enough to anonymize the information presented in the graph? Not necessarily, because you can still use a lot of publicly available information to de-anonymize. So let's say, for example, in this particular case, somebody knows that let's say if they know a subset or all the persons that are represented in the graph. Okay, so you just somehow they are able to figure out the names. And if you know from the information that you have researched that among the set of people, you only have 2 people who have 4 mutual friends. Okay? So if you look at the structure of the graph here, there are only 2 nodes that are connected to 4 other nodes. Okay? So if you have that information that you have, you're only among this set of people, you only have these 2 that are 4 mutual friends, you can go back and reverse engineer and guess, okay, so one of these is Alice, the other is Bob. So, so this gives you a simple instance. So once you've identified that, you know that this edge connects Alice and Bob, and you can use that information to build, to go back and research and build, to build on that and develop additional information. So it gives you one simple example of how simply removing identifying information from graph data is only doing that is not adequate. Okay. Now here's another example. It's called a friendship attack, whereby let's say the identifying information has been stripped out of this particular graph, and so here the vertex degree is essentially the number of nodes that are connected to each node. So if, let's say, this particular person has only 2 friends, you have 2 edges coming out of this node, and so on. So again, if we know if the vertex degree is publicly available, it's possible to reverse engineer from this particular graph, try to guess back and see, I re-identify some of these individuals. Okay? So, so these are 2 simple examples. There are a host of other examples that we can imagine whereby we can de-anonymize graph data. Okay? So here's another example whereby you have 2 communities. You have one community of individuals belonging to this category. You have another community. Now, if somebody knows that a particular person called John has 5 friends, okay, and if you go back and look at this anonymized graph here, there's only one node here that is connected to 5 other nodes. So that means if an adversary knows that John is the only person among this group of people who has 5 friends, then by examining the structure of this graph, they know, okay, that's John, so, John has a particular, it belongs to a particular community. So again, there's a danger of just naive anonymization of graph data. You can still give away information. Even though in the anonymized graph, if this is not, this label, the community category is not de-anonymized, it's giving away a lot of information. Okay? So similar to data tables, you also have privacy models for graph networks, okay, different categories. We don't have time to go through different privacy models. If you look for, if you Google, for example, privacy anonymization models for graph data, you'll be able to get a lot of information. Essentially, they look for the structure of graphs, okay? And so for example, in this particular case, if we modify the structure of the graph in such a way you can remove some of the edges, if you can add some dummy edges, et cetera, you're modifying the structure of the graph. And that way, you can de-anonymize some of the information. Okay? Simple example. So essentially, if you look at it, data mining can expose private information, sensitive information, even if identifying information is stripped out of the data that's supplied to the data miner. So an important issue is to be able to identify, in addition to the identifier, what additional attributes in the data that is supplied to the data miner can be linked with external information from other databases to re-identify individuals. So proper anonymization techniques must be used to ensure that sensitive information is not leaked with data mining process or data mining results. So it's a lot of information, a lot of work that's been done, a lot of information that's out there, something to be aware of. Okay? Sorry it took a little long. I'm a college professor, so I tend to lecture. So that's
Does anybody have any questions?
Talk about the 4 data mining process, right? And
steps? Are you talking about
the steps?
Yes.
The steps.
Yes.
So do you all use ETL, extract, transfer, and load? Is that still impossible, extracting data? Between the extract, transfer, and load, between the extract and transfer, you pulling data that you don't need and pulling it out. And after you do the extract, transfer, and load, you load it to another database. So you're cleaning the database out.
Right.
Okay.
Right.
So we used that in AT&T. That's why I was a BIDW project manager. Did it eliminate the ETL process? Do you know about the ETL?
I haven't done a lot of work on ETL, so
Okay.
I'll have to look it up and
Okay.
see if that's available.
Okay. Okay. It's kind of similar to that. I was wondering.
Thank you. Any other questions? Thank you, Dr. Krishnan.
You're very welcome.
Really appreciate it.
Thank you all. Thank you very much.
Just a reminder, is Brent here with the scanner for the continuing education session? If not, if anyone, just a reminder, this session does qualify for continuing education. There's supposed to be somebody here that's scanning badges. If that person's not here, I'll take a picture of your badge, and we'll work with that to get the documentation to you. I want to thank you again, Dr. Krishnan.
You very
Thank you to St. Leo University as well. That concludes this session. Have a great day.